Welcome everybody. My name is Mario Tapia. I'm your host for tonight. I've been curating the Mobile Mondays meetups for 16 years now, since '99. So I've done over 300 of these in the past couple of years. But wanted to welcome you. How many tonight is the first time to a Mobile Monday? It's always about half. Yeah, all right. How many people doing? Yeah. How many people doing working on Internet of Things? Connected devices. Wow. How about anybody with smart cities? Working in smart cities? Yeah. How about connected car? All right. Health and health. All right. Awesome applications. Great. So I think tonight, definitely tonight's topic resonates. Will resonate for you guys. So, let me use the agenda for tonight. We'll just go through a quick welcome. I'll give you a quick overview of Mobile Monday, and then we'll have a presentation on 5G from Qualcomm's perspective, and then we'll jump right into the panel. And I think for panel, the rules of the road for the panel is raise your hand if you have a question, ask a question, no statements. So I'll move on from you if you have a statement. So it's no monologue. So,
question. The 5G presentation, will that be available later?
I don't know if that's available. And then we can talk about it later, but if not, I can always do a follow-up thank you and then point to it somewhere on the website. So a little bit of Mobile Monday. I currently kind of curate Silicon Valley, Silicon Beach, and also Silicon Alley, New York, which makes us about 30,000 plus of folks just like you in these different communities. In the U.S., we're pretty much cover most of the tech hubs. We are a 501c6 nonprofit trade org. How many people have been to Mobile Monday outside Silicon Valley, another city? All right, pretty cool. So, and also it's global, so it's 140 cities worldwide, very grassroots type of organization. So, kind of like, well, who's in the audience, right? And so, about a third of you write code. Actually, how many people here write code? See, how many people here are business development, sales, externally focused, product and marketing, product, media? Media? Bloggers? So you also have venture, we like to hide. So I won't ask for them. There probably is more VCs than UI people, which is ironic. It's just UI people are definitely unicorns. So there are four type of engagements that we do. We have our monthly topic, which is here. You might have seen our Mobile Monday Labs last week. This is where we do kind of a deeper dive. It's our technical session. And so we've been doing a lot on IoT. We do have one coming up October 7th. If you guys are interested, this will be focused on prototyping. So we've been looking at the Qualcomm Dragon Board, which is a new platform that has come out. It's very awesome, very powerful, also very tiny. And we've covered developing for the Internet of Things, designing, and then we'll be covering prototyping, which is 3D printing, laser cutting, etc. Those different types of stuff. So I'll probably send a follow-up email, say thank you for this event, and we'll have the link there. And then we also do our roundtable dinners, and then we have something called Mobile University, which is one-day deep dive sessions. And a lot of big names are behind us. This is where to find us. So how many people find us on Meetup? Good source, yeah. It's funny, if you go outside the US, no one uses Meetup for events like this. Twitter, we're at MomoSD, and also on Facebook, you can find us at Mobile Monday SD. We record all our events. You can find us on Mobile Monday SD on YouTube. So we have about 5 years worth of history there on different events. And also I'd like to give a round of applause for Qualcomm. Thanks to the folks from Qualcomm. All right, so next we'll have Rasmus.
So I thought we should start out with giving an overview of the 5G and what it can do before we go to panels. So that's what I'm planning to do. Okay, so the question was if you can get the presentation. Yeah, you can absolutely get this presentation. We have tons of stuff on the web. I think a lot of companies have that. So if you go to qualcomm.com/5G, you can get this presentation more. I'm sure that Ericsson has something similar. If you go Ericsson.com/5G, you probably can find. Is that right? Yeah.
That's correct.
So yeah, you can find more than I have in this presentation. I think I have maybe slight variation of it, but soon you will have much more on our website. So this presentation is more about the vision. If you want to understand exactly how 5G is going to be implemented, that's something we haven't really maybe so much on the website yet. But during the fall, a couple of months, or it's been 1 month, and during the rest of the year, we will have tons of information exactly how it works. So, but this presentation is what it should do instead of explaining how it does it. So. Mobile has made a leap every 10 years, so it's time again. And if you look at 3G, in some sense it introduced more broadband, and 4G made it better, faster, and better. In some sense made everything right that was introduced in 3G. But 4G has also been evolving gradually and adding more things than mobile broadband. It's things like device-to-device communication, optimizations for low power things like machine type communications, broadcast, also unlicensed spectrum. So that is going in a new direction than it initially was designed for. So we have an effort we call creating the connectivity fabric for everything, and that's sort of what you need to connect everything. You need Bluetooth, you need Wi-Fi, you need LTE, and 5G is going to continue on that path and rising up to meet the significantly expanded connectivity needs in the future. So to do that, if you look back at the history, we have to do things different than we have done initially. I mean, when we started out with mobile communication, we had more human communication, so we had to scale to connect virtually anything, everywhere. And that's something we're already doing in the LTE Advanced. We're scaling down to machine-type communications, for instance. I don't know if you follow the debate, but it was a compromise that happened last weekend, the stabilization between different proposals on narrowband communication. Best effort data, that's how we started out with data. I mean, going forward, we also have the new kind of ultra-reliable services and discovery services. And that's something where 5G can do something different. Because we haven't really focused on something extremely reliable for sort of mission-critical use cases. And that requires a new thinking, a new design. Discovery service is something that's already been introduced or being at least proposed and is part of LTE standard. And specifically, we have something called LTE Direct. So that's I hope many people have heard about. And that is also part of the new area here that devices today is more like an endpoint. At least in LTE and 3G. So in this new era, devices is also new intelligent ways to connect and interact, and device to device, and multi-hop, and mesh, and integrated backhaul, and so forth. This is ideas that has to be included in 5G. And we also see this convergence. Already today, we have convergence between LTE and Wi-Fi. We have features that makes it easier for mobile operators to leverage unlicensed spectrum by integrating Wi-Fi to have, for instance, link aggregation or even deeper aggregation. So one thing that's going to happen for 5G is that you will see that licensed and unlicensed spectrum is going to be designed from the beginning. It's not going to be added on. So what is 5G going to do then? It's going to connect new industry and new devices. So if we can scale to more use cases, then we can do today. We can connect definitely more. We can enable new kind of services. One example I mentioned before was this kind of mission critical control. If we can bring in extreme reliability that we can't, or ultra reliability, that's what they usually call it, then we can definitely control new industries, automation, critical infrastructure, and so forth, and enable new kind of services. And we can also empower new user experiences. And one example is today we are focused on peak rates. making LTE better and better, higher and higher peak rates. But peak rates are typically only possible closer to the base station. Obviously, it depends on how densely you put base stations. So one area where you can focus on here too for empowering user experience is why not also make this broadband uniform, so it's really good everywhere to have, so it doesn't go up and down depending where you are. So that's one example where 5G is something. So we collect this under 3 areas we have to do to meet these kind of requirements. And it has to be scalable to an extreme variation of use case and services. I'm going to them in detail later. Edgeless, if you have this new network where you don't experience the notion of cell edges, both from the capacity or coverage or user experience perspective, you can call it edge because you don't see any edges in the phone. And we can create this unified platform that now can support all spectrum types and bands and more service and voice model. And there has been a debate, I don't think it's debated anymore, but 5G is going to cover low bands for good coverage, like below 1 gigahertz. That's really good, for instance, for sensors or IoT examples that has a lot, not so much power, up to normal spectrum bands from 1 gigahertz up to 3 gigahertz. That's the traditional mobile broadband. You also need it for instance, mission critical kind of services up to, it's not officially even 6 gigahertz because the ITU has sort of assigning spectrum below and above 6 gigahertz. Been a debate if it's going to go, when it's going to go above 6 gigahertz. The 6 gigahertz it has a lot of spectrum above 6 gigahertz, and you've probably heard a lot of discussion on millimeter wave. That is going to be important also to leverage all this spectrum that's out there to get much more capacity. But it's very important also to design 5G for all these low bands to get the foundation right. So this is the standardization. So it's funny actually, what you see happen at the end of your side, is left side, is the 3D brand workshop, and that finished on Friday. So that's just happened. So that was the first real effort to define the radio interface and the 5G network. So that means that the standardization just started. So they will work on some study items, then in something, I don't know if you're familiar with it, but the standardization 3GPP has releases. And they're working on release 13 right now, trying to finish it. They're going to start on release 14 soon. And then release 15 is where the first 5G effort is going to be standardized for commercial launches in mid-2020. And it's going to be second phase with launches in 2021. So it's not possible to do everything that's planned for 5G in the first phase. You have to phase it. And obviously it's going to be an evolution of 5G as it is with LTE today. LTE Advanced, LTE went to LTE Advanced and so forth. And it's been continuing on for multiple releases. I don't know if you know the history, but LTE Advanced started in release 8 and it's now been going to release 14. So it's been enhanced for multiple releases. And in parallel, LTE will evolve here and they continue to do in many ways similar things that 5G is going to do. Or you can say also that some of the stuff that we are going to do now in 5G actually started in LTE, like device-to-device communication, incorporating unlicensed spectrum, broadcast, making that better, optimizations for these low-cost, low-power things for massive IoT. So this is an example of the 3 main use classes that most in the industry are talking about when it comes to 5G and how extremely different kind of requirements they have. So how can you really do this? So if you look at mission critical services, that's the area I talked about. Like, if we could make something extremely reliable, what can we control then? And I have several use cases later on, so I'm not going to discuss the use cases. I have a specific slide. And some of these control cases might need extreme low latency, as low as 1 millisecond. And mobility has to be flawless. Then maybe you have to do something different. You can't maybe not just have 1 leak, you might have 2 leaks to make it extremely reliable. So that's something new. Or extreme fast failover if 1 link fails. And mobile broadband is still going to be very important, so but we can still enhance it. It's both extreme data rates, multi-gigabits, or uniform rate, and we have extreme capacity, we have to do densification, we have to bring the the way to get more capacity is to leverage more base station closer to each other, I would say, not or, but and leveraging more spectrum, like going up to higher bands, like millimeter wave. And then we have a lot of Internet of Things stuff that requires extreme low energy, extreme deep coverage, for instance, and ultra low complexity, which is completely different. And now we say that we want to create this unified platform for all of this. How would that be possible? Because if you do something that has extreme more broadband, it costs a little more because you have a more complex receiver or transmitter. If you want to have something from massive Internet of Things, in some cases, some IoT things require something really cheap and simple, and a very simple receiver and very simple transmitter. So how do you do that? But that is not exactly what I'm going to discuss today. But that is something the industry is working on. I'm going to focus more on the use cases. But there is a solution, it is possible, and there's a lot of proposal on how we can actually do this in one unified proposal. So this is what I talked about with what I call edgeless connectivity. If you can get user experiences more uniform, so you don't have the notion of coverage or cell edges as you have today. When you move between around, you don't feel like there's no. Then we call that edgeless, and it could be both from a capacity perspective, that you have massive MIMO or beamforming that clears the capacity to you. So when you move between cell sites, you don't feel this traditional dip in capacity as you do today, maybe when you are close to the base station. But also that you can connect directly to people around you with device-to-device discovery communication, vehicle-to-vehicle, vehicle-to-everything is going to be important. It's already something that's happening today in advanced, for instance. Integrated access and backhaul. The example on the left side is interesting. Specifically, if you think about a low power, low complexity, let's say sensor, put it in the basement. So how should that be able to reach the base station? Because you don't want to have, if it is battery power too, because that means that you have low transmit power. So it probably can't reach the base station. So the uplink is probably, the downlink to the device is usually not a problem, because you can blast a little bit more power from your base station. So then it's very useful for the uplink, for instance, to do the mesh. If that device can see another device, then we can solve the uplink problem. And we can have a managed mesh, and in most cases, the base station can actually reach these devices with downlink, but in uplink, then to get the coverage, you can use this. So then the next slide I added because I thought it's a very nice animation, that now it's going to show how we accomplish this edgeless connectivity. So it doesn't say anything else, but just a nice animation. I like it. Okay, so then we'll go quickly into some of the use cases. So if you're going to scale up to extreme broadband, so here's some example use cases. Don't take all of these numbers as given, for instance. Some of the use cases that we discussed is virtual reality. We need enormous, we need quite high data rates, low latency. So that's like 50 milliseconds here. I heard some companies saying like 10 milliseconds or less. So it's probably less than we need. The tactile internet is something that's been discussed a lot on how you get a low latency from action to feedback. For instance, the example here is time from joystick action to virtual object movement with haptic feedback. And that is use case that we discussed to get latency end-to-end down to 1 millisecond. So that is something new that we don't have today. But that's also something we're trying to do for LTE Advanced as well. We have something called ultra-low latency there too. But you can definitely do it better here in 5G when we start from scratch, and we can even go below 1 millisecond. Rich media is going to be very important. I mentioned broadcast before, but Ultra HD video streaming, and you see some example here of quite impressive data rates you will need. Ultra fast media download is another example that's interesting. If you have like a kiosk at the airport before you go on a flight and you want to download something, and you want to download a big movie in a couple of seconds, that's another use case could be used. But that's also something we're doing today actually. That's a use case we're looking into for 802.AD. Question?
So people today use lots of different protocols in their homes or offices, Bluetooth, Wi-Fi, 4G. Does the 5G model simply subsume all of those also, or replace all of those? Or
no, that's a good question. So as I said before, I mean, we have this effort, creating connectivity fabric for everything, connect everything. That means that you can't use LTE to connect everything. You need Bluetooth, you need Wi-Fi for other things. 5G is definitely going to expand to a bigger role than it's done today. I mean, we incorporate a lot of things that we've done very advanced, for instance, with the unlicensed spectrum. But you probably have to do something different if you want to scale down to something as extremely low complexity as Bluetooth. And currently, there hasn't really been any focus to scale down to that extreme level. So we're talking about a managed network that has inherent benefits by using both licensed and unlicensed. But there are definitely the usage model that we discussed for 5G that's only using unlicensed.
Does that mean that when two devices communicate peer-to-peer in the same office, they're going through the base station?
No. So we can. Yeah, I didn't go into the D2D here, but the D2D is interesting because it offers an opportunity to use it in licensed spectrum for the operator to offer a service for proximal discovery, something we do with LTE Direct. But when we define 5G for unlicensed spectrum, there's nothing that prevents it also be used in unlicensed spectrum, device to device, between users that's not operator managed. So yeah, we have a use case, other use cases. But we see that we need really high performance and low latency for many of these cases. And we also have to scale down to low-cost thing. This slide is a bit complex, but I think there was a little bit too much information. I don't have a better one. But well, I think one interesting thing is where 5G is going to add value to. Obviously, to connect a lot of things, you need different technologies today. But 5G is also going to have focus on really low complex communication for low power things that also need mobility, because that's a challenge to do together. So you see, for instance, we have some example of object tracking. We have wearables and fitness that definitely require mobility. And also some things in the smart cities that require mobility. But on the other hand, if you don't need mobility, you shouldn't burden the design with having the design for mobility all the time. So you have to do something new and different so you can sort of have mobility on demand. And also design it in a way so you can support these battery-powered, low complex things. And that ties in both what you have to do in the air interface and what you have to do in the network. But as I said, if you have time, we can discuss that in the panel, but that's sort of the next level of implementation, which a lot of companies, including Qualcomm, have a lot of proposal on how we can do. And I encourage you to get a check. You can check our website in the future if you understand exactly how it's going to be done. The third area that's interesting is this new ultra-reliable, low latency, so-called mission-critical services, where you can get to new levels of reliability that is not really hard. It's hard to do today in the existing design because you could do it, but you get this like a trade-off between latency, capacity, and the reliability. So when you do it in a new design, you can get a much better trade-off between these parameters. For instance, if you have normal services like mobile broadband, and suddenly this mission-critical information or control is coming in, you don't want to wait to schedule that, or maybe it has to be sent immediately on top of everyone else. Then you have to do something new and different than before, so this could work with the other services. Yeah.
Can you give an example about industrial automation as a critical service that your vision?
So yeah, I mean, the process of automation. Someone in our company found use cases where you can control something in the process automation where you need really low latency. I don't know exactly which processes there would be, but that's and then maybe we can discuss these use cases with other people in the panel that have more better examples. But at least that's what. I mean, I think the other example here is more easy to understand. If you have human-to-machine interfaces for this industrial control, then the tactile internet and augmented reality kind of solutions is easy to understand. And if you do it, then we get back to the other use case of tactile internet where you need end-to-end latency as low as 1 millisecond. Automotive aviation always comes up. These numbers, I've heard many numbers. I heard people saying that you need much less low latency, and I'm listing here. Like the automotive here is from some federal agency, so it's not like it's really possible to do lower in 5G. Aviation robotics, I heard an interesting perspective. Someone said that, yeah, I would love to have 1 millisecond latency. But on the other hand, when the robotics or aviation or drones becomes more autonomous, maybe it's not needed, then they're actually fine with 20 milliseconds, something like that. So depends on the use case, obviously. But this, at least give an overview of the 3 main areas that we're looking into: enhanced mobile broadband, so massive number of things, so massive IoT, and new ultra-reliable, low-latency mission-critical services. Okay, so this is just a summary from, I think I not used more than 50 minutes, I think that's what time I should use. But if you summarize the view on what it is, I mean, it's a unified platform for expanding connectivity need. I didn't explain all the unification, but it's about unifying all the spectrum, different deployment models. So we go from low bands to high bands, up to millimeter wave, licensed, unlicensed spectrum. We can deploy from hotspots in home, residential, to enterprises, to traditional wide area networks, and so forth. Edge-based connectivity, I explained, that in our view, that's a new way of connecting things and interacting with things around you to create this feeling of there is no edges anymore. You have, for instance, also uniform experience in terms of capacity and mobility as well. And something that I haven't covered here, but it's pretty important, is the cost and energy efficiency. And to do that is also about defining a new network, both from radio and core network, that is energy efficient and cost efficient. I mean, one thing that's happening is a lot of this virtualization that's going to happen in core network. But it also has to leverage 4G and Wi-Fi. And that was not covered in my slides, but I think most in the industry are agreeing that you need a solution so you can have a phased introduction of 5G, so you can leverage the investments in LTE and Wi-Fi today. So some of these things that are being introduced is that you have something called multi-connectivity, so you can connect to both 5G and Wi-Fi and LTE simultaneously, and also that you have a new core network that also connect to 4G and Wi-Fi to leverage those investments. But another thing that's happening is that a lot of the things that's being developed for LTE and LTE Advanced today is going to be the foundation for 5G. And the fourth point is that we need is scalable for new services and devices and new verticals.
You've got a Bluetooth accessory that ties to your phone and that's using some form of data in it. We make no additional revenue off of that model, right? It's coming out of your straight plan as is. Essentially, we're really not adding much more value into it. So we're trying to figure out what value can we add in order to actually have a play in there. At the end of the day, you're not going to pay, to use your term, gouging rates if we're not adding any value. We've got to be adding value. And so our whole focus is on what can we provide as a network provider that actually is useful to the end customer, that makes their life better, that provides perhaps security and reliability and trust along those ways, where it's actually now something that makes sense for you to open your pocket for. Otherwise, it's not worth it for you.
I guess there,
Yeah, I
so,
mean,
yeah.
since Sony have the 4K display mobile phone, and YouTube also have 4K video already. So I'm just curious, since LTE also have the 4K small before, so do you think 5G will provide a 4K small service later? Because that's the best way to balance the spectrum utility role, right? So if we don't provide the 4K to the mobile later, probably many people cannot see the 4K or bigger than 4K, like AR/VR content in the mobile later, right?
I think we can expect that 4K will be part of what we deliver to mobile.
Yeah, but it's still streaming or just
So 4K is commercial in mobile devices, and we have multiple chipsets that support 4K. So it's a matter of getting the screens and devices up, and some devices have been coming out. So it's not a limitation on the network, and we have demonstrated broadcast over 4K, I think, for 2 to 3 years at trade shows. So I think it's coming there.
yeah, but right now the business model is the data is unlimited data.
Yeah, I mean
It's
that-
not the limited data.
No, nobody asked about when it's coming. I mean, it is coming. It's there. It's there.
Yeah, but if you look at 4K content by streaming, that will be very expensive, extremely expensive, right?
Yeah, but
Yeah,
as I
it's
said,
a
it's some-
problem.
yeah, but that's why broadcast is a good model for that. If you want high quality model, that's why broadcast is an excellent model. And I think that's something I touched upon also in my presentation. Like if you look at a lot of things that's done for LTE, you started really to focus on mobile broadband, making better, bigger data pipe. And then we added on things like broadcast was added on later. We added on LTE Direct, we added on MTC optimization. So for 5G, you have opportunity to do something from the scratch. So then you can have native broadcast from the beginning, and hopefully you can do something even better. And I think, yeah,
Or
broadcast.
do you think the next generation digital TV will also consolidate?
Oh, that's a very good comment, because that's something that's happening in Europe. So you have the digital divide in Europe, 700 megahertz, that's used by terrestrial broadcasting. So that spectrum is going to be freed up, and depending on how fast it frees up, I mean, it could be LTE and BMS that's actually used for it, and or 5G, depending on the time frame.
Hey, Ron, let's move on. Oliver, let's go next, and then we'll get you. And then.
So we all know that to move to a new generation is hugely expensive, multiple billions of dollars to buy expensive.
There's a reason we have put the rates that high.
And to deploy the networks and then to get new devices. So it's huge. So in the past, what drove adoption was really competitiveness at the carrier level, right? You needed to have that. Are we going to see that again? I'm a bit skeptical now that the LTE is good enough, that there won't be the competitive pressure that there was in the past. It's going to get a carrier like AT&T to spend $10 billion to roll out.
So we just bought this company called DirecTV. I don't know if you read about it. So video is a really, really big part of what we expect will be on the network, and so I disagree that there isn't a competitive forcing function, even internally driven, to make the networks be able to support that.
I think it's like hiking, Oliver. It's like the bigger the backpack you get, the more crap you put in it. And how many people said, like, remember, hey, you know, one meg is just enough for memory, right? Yeah. So remember, and I think when you build networks that can take X capacity, you guys are going to be able to max it out. You'll build something, right? And I think that's the evolution of technology, right? It's like, I don't think we're going to conform to like, yeah, LTE's good enough. Hey, you know what I mean? I think that's the reasoning. But yeah, let's go over here.
Switching gears a little bit. Talking about security, today IoT implementation have several layers of security and like 8, 9 to make sure that's quite safe. So imagine that you already have deployed, and 5G for sure has a huge definition implementation there. Short answer is how can be more effective the security part, not just between point to point, but between the own spectrum, like avoiding people to not clone, because clone is too child, but something that protect end to end. And if you guys gonna create something that have APIs or sort of APIs that you can instead have like a 10 or 15 demos running on your application, you're gonna rely more in the network. So it's a quick answer would be great.
Sorry, this is something that I really, really care about, so this is one that I love. So look, there are a lot of pieces what I was talking about on the infrastructure side of it, identity being one of them, which becomes the underlying basis upon which can you trust the devices that are providing the information along the way. There is, and I see a lot of companies, right? I see about 600 companies a year. I have yet to see anybody focus on building a DNS of things. In fact, if anybody here is thinking along those lines, please see me afterwards. I'm really looking for something like that. But this notion of being able to have faith in every single device and addressability along with it, being able to make sure that every point of it is something you trust. Why does it matter though? I mean, think about it. You think that, why does a temperature sensor need to have a lot of security? Well, because a lot of temperature sensors are tied to your alarm system. When your alarm system detects that the temperature gets really high, it turns off the alarm system and turns on the sprinklers so that people can easily exit the building. Well, somebody hacking into it can basically open up your doors that way, if you think of it. So there are a lot of scenarios where something that you think is honestly not something worth paying, but you really, really have to. Now, is that something that we can provide as a network provider? Maybe. There's a solution around that. We don't know. We're still exploring, but really interested in understanding how do you provide addressability and trust on the scale of not just what you do right now with the hardware and SIM, but really go out to hundreds of billions of devices and each one being uniquely addressable and trustworthy, and yet still have some record along the way for transaction monitoring purposes.
Yeah, Miss.
How do you see projects like Project 5 in this adoption to G5? Because I mean, if Apple were to make that announcement, a couple weeks ago, and said that they had something like 5, where they were just, they're going to be their own carrier.
I'm using it.
So one thing to note is that 5G is positioned to be kind of the ultimate cure-all,
Yeah.
right? And there was a statement that says, if they could execute 5G correctly, there will not be a need for 6G. That's a very, very bold statement, right? But that's, just a war, the war zone ready for, fighting over frequency and standards and everything else, so we don't know yet, right? But Google needs to play into this part because they are becoming part of this infrastructure player.
That's right.
And so it is a good deed that they're doing. We don't really know what kind of evil things that they might have up their sleeve, but I didn't say that. But they need to be doing this so they could understand the implementation or implications of their network security and everything else, right? And so Google, amongst everybody else, they're looking at this, realizing that there's going to be a huge can of worms that's going to open up, and to kind of address what's going to drive all this need, it's an iterative process. Right, and then at every G, the telco and 3GPP and all the standards committee has missed their projections on how it's going to be used. Right, it wasn't until YouTube came out, that all this video on our smartphone was really pushed, right, beyond its expectations. So somewhere along the lines, as 5G is getting standardized and developed, something's going to push its limits. Nobody really knows because we're not there yet. But it is a collaborative and iterative process, right? And so I think 4G was one of the first times that I saw a lot of other players from different industries come together to kind of give their insights and their needs and their frustration or pain points that they're foreseeing. And so as the collaborative ecosystem gets bigger, they're going to be able to prep for it.
So hold on, let's move on to the next question because Jay opened up the next question. The benefit of a unified platform, right? Because right now, if we roll back the time, I don't know, maybe 7 years, we had, how many people have Verizon right now, right? I mean, that implementation of 3G and LTE, you still can't talk on the phone and browse, right? Proper implementation, AT&T users have been doing that since 2004, right? With the 2.5G implementation, right? So that's the benefit of a unified platform, is that the experiences are all the same. How many people 10 years ago had to get a different phone when they went to Europe for different frequencies, right? I mean, you can remember that. How many people were Verizon subscribers that had CDMA and then had to get a GSM phone? What the hell is a GSM phone? Most of us in our industry did that. Well, so let's talk about what are the benefits of a unified platform on a global scale, right? Because the Chinese are really engaged right now in terms of spectrum and very interested in harmonizing, I guess, all the rest of the continent. So I'd like to get some feedback on what are those benefits.
Yeah, so you take the example of the devices that they need to be unified, and the services, when you migrate between two generations, also need to be unified. But with 5G, with many new industries coming in and new different slices are offered, there is also a benefit from an ecosystem being able to offer a certain healthcare variant that is unified between different healthcare companies and so on, or car industry that also can use the common ecosystem, common platform, accessing the different operators' network in a unified way, which means that they can build their ecosystem outside of the operator's domain, but still being able to offer different type of services from different operators globally.
Yeah, so I got this question a lot to say, like, I mean, if you go to explore all these use cases, they're so extremely different. Why wouldn't you add costs to some of the use cases if you want to do something with unification between the spectrum and the use cases? Yeah, if you don't do it right, that's true. But if you do it right, you can have this scalability. For instance, a big example I mentioned, they have mobility on demand. You can have optimized waveform for different solutions and use cases. And still, for most of the use cases, you get economies of scale and benefits to have a unification, a common, for instance, unified air interface that wasn't really possible before. So it's not only about the unification of the spectrum cases where we travel, but it's also about getting a more cost-effective platform that can scale to these different use cases, and it's flexible enough and dynamic enough to not burden different verticals or services with overhead from the other use cases. So that's a lot of challenges to design.
So we're really, so we've made a lot of public statements around what we're doing at our network level to make that interoperability across, at least at our network side, on the core network side, how to try to move away from the model that we had in the past, which was more proprietary software, hardware, appliances, and move now to, in as much as possible, commodity hardware and open source software. So, this is a really big move for us as a carrier to go out and say, we are very heavily behind the open source movement for infrastructure software. So we're big supporters of containers, we're big supporters of OpenStack. We really, really want to diversify the ecosystem of vendors who can provide products that actually work and interoperate in our network. And that, in turn, makes the interoperability and the cost basis for us much, much lower to be able to provide a service that lets the end user and consumers have many more services that will have a lower cost basis to it. So to your point, you do need to get to a point where you can work nicely with everyone else, and supporting open standards is a really big way to do that.
So the future satellite video broadcast will use the LTE standard or use the Europe DTV standard?
I don't know, to be honest, so I can't give you an intelligent answer on that.
And hold on, the questions, wait till we call it, raise your hand. Oliver, go ahead.
Yeah, so right now I work in the video industry, and there's a big push for World 3 codecs, and they're heard about that. The interesting thing is that the 3GP impact is on many orders of magnitude larger. So my question is there any push to make 5G work as they need?
In what sense?
Well, the patents that you pay to use 4G technology is huge. On cost licensing, maybe 20% of the cost of the phone, so $200 on an iPhone, is just going for the people that invented the 4G cellular technology. But yeah, I wondered, the video side, there's a huge pushback to get rid of what is a much smaller amount.
This is a good question for our host, I think.
So 5G is going to be standard at VDP and all of the licenses, all the IPR. Can you hold the microphone?
Yeah.
You mentioned that before. 5G is going to be standardized by VDP, and 2B have this patent kind of agreements in place, and that's going to be following the same for 5G.
So fair, reasonable, and non-discriminatory, just the same as the video. But even so, other players in the industry are now saying we can't afford to pay anything. And I wondered if that pressure will come to 5G.
I mean, I don't know what the last number is, but there's tens of billions of dollars that have been going into R&D work for 5G already. So they need to recoup the cost, unfortunately. That's kind of the economics of how the licensing play works. So there's a reality piece to it, which is that someone has to pay to recoup this benefit, and I think that's, I think the end user ultimately has to pay for it. But with the video standards too, if someone has an amazing H.267, I guess, new codec and wants to give it away, by all means, right?
So I completely agree with you. There is tens of thousands of patents in video in exactly the same way. I just don't see why people are unwilling to pay for it in that case.
Sure.
A huge amount of investment.
Let's go, question over here. Yeah.
Comment on the video just briefly, which is, should all be IP. You know, the dream was to have IPv6 on everything, and at which point the codec software, and we've got fast enough CPUs that this whole network's going to be built on software-defined radios and direct synthesis, and we're not going to be using analog or even digital synthesizers, but we're going to be generating our waveforms with CPUs mathematically.
Actually, my company makes a hardware encode. What I do in hardware, 64 Intel i7 cores, 4 gigahertz.
Yeah, today's are changing fast. Anyway,
4K real-time question here?
no, actually, it's not even an issue. You should see some of the stuff I'm playing, but that's it. The question I had was emergency services. So, you know, 9/11 happened, the Metrocom network with a company was bankrupt, and the hardware was still laying there attached to power poles, was one of the few radio networks that was still functional enough. You know, I just came from Fukushima, Japan. The big concern was, again, how do we build a reliable radio network that's going to be available? And, you know, this is great. We can do gigabit and all this fantastic stuff, and all of a sudden we have an earthquake here in California, or, you know, some sort of disaster scenario, and we're all going to be in the dark. Or, you know.
Well, I mean, there's like FirstNet. You've heard of FirstNet, right? It's an overlay LTE network that is specifically for first responders. But how they're leveraging the payment is they're actually running commercial software on it, and then in the event of a disaster, commercial traffic is cut off, and then it's.
Well, that's not really good either. I mean, it'd be nice if you just limited it to, let's say, phone calls or text messages. So, you know, something where family members could at least know they're okay, but not allow, you know, kill the internet and a lot of the other bulk stuff.
So for us,
so there's a lot of work that we're doing on that right now. Right now, we've got, you know, the way that we augment the network right now is through something called CAL, cellular on wheels, right? We've got a van that rolls around with an antenna that pops up, and when Katrina happened, we deployed a bunch of those out. I mean, I think we're much better now than we were at 9/11 for sure. But there's a lot of work going on in that. FirstNet was a great example of it. There's work happening. I mean, you're familiar with some of the stuff that Google's done with Loon, with Project Wing, with, you know, other ways of being able to create a network using aerial vehicles or other mechanisms. There's a lot of work happening on that right now. We're not nearly as badly off as we were at 9/11 timeframe, for sure. I don't think we'll have that sort of disaster scenario because we have enough alternative ways of flying in a network or coming up with alternative methods really quickly to take over, even in the worst of situations. So even if an EMP happens, you can still bring in other devices to bring them back up, to bring a network back up in literally a space of minutes or hours.
Yeah, because just think about it, in 9/11, what were the networks like back then? How sparse they were, no mandate for the, you know, if there was a power outage, they had heavy battery power for 8 hours, 24 hours. Wi-Fi coverage also wasn't as ubiquitous. And if we look today, I mean, there's a Wi-Fi spot every 100 yards now. You know,
Well, I know.
hop on there.
Power grid's out, all that Wi-Fi is gone.
Well, once the backbone, yeah, but basically when copper goes out, and then maybe you have, you know, with the microwave, and if that gets out of alignment, then.
But the other piece of 5G can actually not replace physically damaged equipment, but all the capabilities with virtual network or slices will also help in this case because you can slice for emergency, which means that all non-essential traffic might be shut out in these type of areas.
But you stumbled on something that's interesting because we were going to talk about mesh networks, but how do mesh networks and 5G, you know, the concept of 5G, do they overlap? Is there what? Because you can daisy chain each other with the mesh network, right? And it's just the last person in San Jose or Gilroy has connectivity, and a person in San Francisco can still get connectivity. If you guys can elaborate a little bit on 5G and how would mesh networks apply?
Yeah, so Rasmus mentioned a little bit about that there are aspects in 5G that we will need for mesh networks, but there is also integration with backhaul where you have relay capabilities and things like that. So enhancing the reliability in the network is one big component in order to build these ultra reliable use cases.
But that's interesting too, because they look at the first method and also look at device-to-device, D2D. So they have actually the capability to use device-to-device communication without power, if you don't have power, so for the first responder. And this ties into also to something, I think, part of what if you have this integrated backhaul and access, even if the battery powered base station, even if the backhaul goes out, you can still maybe reconfigure it and send some of the capacity to another base station, sort of daisy chain them in some way. And also, if you are devices that don't have coverage, you can use D2D communication between devices even to sort of get back, multi-hop back to the network. So these kind of things could also help for this scenario, these sort of mesh, D2D, and multi-hop kind of scenarios. And it's already going to happen in LT Direct with the emergency response network.
So Rasmus, while you have Mike, question here. What is the migration path from current 4G LTE to 5G? I know maybe for most of you it might be a boring question, but some of maybe are interesting. Is it a hardware swap out, which means more revenue for some of the value companies?
This is a perfect question for Anders.
Because what is that migration going to look
But I
like?
think the answer is it's a smooth migration that leverages LTE as much as possible.
Yeah, that's correct. So what we see is that there will be two paths, or two components, and that is part of 5G. One, if you look from a radio perspective, one will be an evolution or LTE evolution, which will be backward compatible so that you can use the same carrier with your legacy phones, at the same time leverage the 5G capabilities of the new phones that you are deploying. Then, for spectrum that is not deployed with LTE, then there is no need for being backward compatible for the devices, so that will be able to use all the new waveforms and new technologies that can be that are part of the development of 5G and the next generation waveform. Over time, phones will change out, and there will be a migration over down to the same spectrum that is used for LTE.
Thanks. Let's. I'll come back to questions. I want to go over two more questions before we go back to the audience. So, and these two questions, they're relevant to each other because one is like, how will 5G enable autonomous vehicles, right? Which we have a lot of discussion here in the Valley, but also how does also 5G play in the smarter city? Because I mean, the low-hanging fruit when we think 5G is like, the industry looks at, well, it's connected car, it's smart cities, which is the obvious, right? But let's go into more detail, like, well, how are these technologies actually going to help, connected vehicles, autonomous vehicles, and also plug into the smart city concept? Because I think until today, right, we had phones, this was connected, we could talk to each other, then we had a few wearable watches that could connect, and now we're going to have all these other things. So how do they all, in your vision, how do they all play with each other? What are some of those? And Jay, I know you're a visionary on this. So it's 2020, it's 2030, right? And you get out of your house and you jump into what happens.
Yeah. So I've had this long conversation because I like to drive, and I don't really like to give away the fact that I lose control, right? But just because I like the feeling of driving, and I like the thrill, but over time, I'm stuck in traffic for an hour a day each way in my commute. I would just rather just sit there so I could catch up on emails or whatever. And so in that 15, 20-year timeline, if all these cars could intercommunicate with each other and make decisions and talk to each other, right, then, we'll significantly decrease accidents. We would optimize traffic routing and paths. It's almost like a network switch infrastructure, really. And so in that future, near future, I don't know how distant it is, but in the near future, that's where we think that autonomous cars are going to go. But there's a lot of steps that we have to do in between it, right? Like even today, Google, you could trick Google's car, right? If you're kind of teetering on the sidewalk, kind of acting like you're going and not, the car doesn't know what to do yet, right? Because they're trying to make sure it's safe, but you have to be efficient and go, and you can totally trick it, right? And so when is the car going to get smart enough to make a decision saying, okay, this guy's holding up a sign that says stop when it's clearly go, And until we go through these really niche use cases, we're not going to get this full autonomous car experience. But in the meantime, there are short-term solutions that we're slowly seeing, kind of like the next version of Waze, for example, to help the driver understand the traffic patterns that's coming, to be able to communicate with the people in front of you to know, oh, there's a huge accident, the entire freeway stopped, and everybody is backed up. So, by the way, you should hop off at the next exit rather than sit here for an amount of time. And so, if we take that concept and we expand it, then the cities will start, the infrastructure inside the city will talk to each other, to the car, and this whole intercommunication will just work, right? And how do we get there? Security, privacy, all that other stuff is another question, but that's where we're hoping to go. With Yamaha, though, we're in kind of this niche case because we don't build cars. We build engines for cars, but mainly our customers are on marine vehicles and motorcycles. We have industrial robotics. And so what that means for us is that, we need to know, as a rider of a motorcycle, we need to be aware of all this information without having a screen, right? And so again, that contextual personal information on demand as you need it is going to be huge. And so I see a lot of the solutions and some of the apps that are coming our way slowly address those needs. And then with the intercity too, it's got to be in slices, right? It's got to be per use case or per needs. And so, I shouldn't care about a light bulb that's out in San Francisco right now. It's completely irrelevant, but how do you filter that out? And once we figure out that right balance, then I think a huge army of service providers and app insight, intelligence providers will come about to create that experience.
In the year 2030 for us?
Well, okay, so expecting everything to be working in real time with extraordinary low latency where the cloud is going to make decisions on when to turn left and when to turn right is probably not realistic, I think. You're going to have each of these devices, and talk to the folks at Google as well, they'll say this, that the car needs to make all of its decisions in its own sphere first, and yes, it will supplement its decisions and perhaps some of the information that will help it make upcoming decisions, but anything that's within the first 5 centimeters to 500 meters is going to be something that is entirely autonomous within that unit. So you'll see a lot more development that will happen within the compute and resource handling within that frame of centimeters to 500 meters range. The networks will supplement a lot and provide a lot more, but this notion of doing remote surgery, I don't think the networks are going to be there anytime soon. Nor do I think we want them to be.
And then there's 802.11p and other wireless Wi-Fi based protocols that are supplementing that, right? Because I just need to know who's around me and to be able to communicate with my immediate network.
So that's